Okay, so if you remember, yesterday this is where we got to. So we started talking about this idea of probability distributions yesterday. Now, what is a probability distribution? What's a probability distribution? What example did we use yesterday? Sorry? Yeah, exactly, siblings, right? So I went around the room and I asked you how many siblings you had. I created a frequency distribution from that, yeah? So a frequency distribution is just simply how many siblings, or how many people had that many siblings, okay? And then from that, I created a probability distribution. So what's a probability distribution? Absolutely right. If I want to work out the probability of an event happening, it would be the number of favourable outcomes divided by the total number of outcomes. But what is a probability distribution? This is what we looked at yesterday. So what is it? Absolutely, okay? So if I have some random variable, so yesterday I used the example that the variable was the number of siblings, okay? Then from that, I can link together each individual outcome, which remember I give by a lowercase letter. So the capital letter represents the random variable, the lowercase letter represents the value, the outcome, okay? And then I can find the probability that that random variable equals that outcome. And yeah, the example which I gave yesterday was something like this, and it had like associated probabilities, so things like 53%, 27%, 7%, and then another 7% I think, and then 0% here. Yeah, so on and so on and so forth, okay? So a probability distribution is simply a way of linking outcomes to their associated probability. Does that make sense? Yeah. Yeah, good, fantastic. Now we started talking a little bit about this idea, which was expectation and variance. So can anybody remember what is the formula for expectation of a discrete random variable? So something like this. How do we work out the expectation? Sum. Good. So in other words, the sum of each outcome multiplied by their probability. So each outcome multiplied by the probability, you just add all those together. Okay? Can anybody remember how to work out the variance of a random variable? And there's two formulas I'll accept.
The sum
Yeah.
minus x.
X bar, good.
X bar.
Or you can say mu if you wanted to call that mu. Good.
The square.
Squared
P.
times by p. Perfect. Yeah? And remember that will work. That will work. So in other words, you take each individual outcome, you take away your expectation, you square that, and then you multiply it by the associated probability. Can anybody remember the other formula that I gave you, that I proved for you? It was involving the expectation.
X. the square.
Good.
The plus minus the x, the square.
Good. Excellent. Yeah? And remember that formula is sometimes slightly easier to work with. Okay, slightly easier to work with that one. Okay? So essentially, each of these formulas are based around expectation. Now what is an expectation? What do we say the expectation was an equivalent of? It's the equivalent of mean. Yeah? Now why do we call it expectation and not mean? Can anybody remember? Why is it called expectation rather than mean? Do you remember the way to calculate mean is you need actual data in front of you? This is not actual data. This is a probability distribution. In other words, it's an outcome and their associated probabilities. It's not actual data. Okay? So we use expectation instead. But it is kind of a mean. Okay? It works in the same way as a mean. It's literally the value you expect to get. Right? But it's not actual data, so it's not, strictly speaking, a mean. Is that okay? Good. Fantastic. And then because each of these two things are built out of expectations, like variance is built out of an expectation, I said we need to be aware of how we can work with transformations of a random variable. So I think I started off yesterday and I said, well, imagine you all had 2 more siblings. In other words, you take your random variable and you add 2 to it. Okay? Now what would the expectation of x plus 2 be equal to?
Adding x plus 2.
Good. Just simply the old expectation plus 2, because of course the expectation has moved with this transformation. But what would the variance of our x plus 2 be?
same.
The same as the old one. Yeah, the old variance x. Because remember, variance describes spread. If you just move everything to the right or everything to the left, the spread doesn't change. Yeah? Yes.
I have a note.
Yep.
The capital X is the number of siblings up there,
Yes.
and in the it is now the smaller x, and
Yes.
it is now the number. So
Good question. If you like, the capital X is the set of every single possible value. Okay? Whereas the lowercase x is just one particular value. Okay? So what I'm saying here is take every single value that you can possibly have and add 2 to it. Okay, so take every single outcome and add 2 to it. Whereas if I was using the lowercase x, I'm basically saying just take one particular value and then add 2 to it. Is that okay? Good, fantastic. Now what happens if we do a scaling transformation? So in other words, we do a multiplication transformation. So what would, for example, e of 3x be? 3 times the old one. Good. What would what would the variance of 3x be?
3
Times the old variance. Good. You remember why it's 3 squared? Why is it 3 squared?
standard deviation.
Good, yeah. So remember, this is describing spread. Now, strictly speaking, if you make everything 3 times as far away from it was before, the standard deviation, which describes the true spread, should be increased by 3. But because variance is the square of standard deviation, you're going to get 3 squared. Make sense? Okay. So please, please, please be aware of these. Okay. You need to know them. There will almost certainly be a question on the exam using these, and they won't be in the formula booklets. Okay. So please be aware of how to manipulate those random variables. So today, I'm going to move on to this idea of probability distributions, but link it to something called a function. Okay? Now, if you remember yesterday, I started to introduce this idea of a function, which is simply you give me a value and I find something else from that. Okay? So it's a way of linking together 2 things. What do you think we're going to be linking together with a probability distribution function? So probability distributions, what does this table currently tell you? So what's on the top row? Yeah, good. So in other words, it's the outcome that you expect. So it's a list of outcomes. Okay. What's on the bottom? Absolutely, the probability of each outcome. So a function, remember, just links 2 things together. It says, you give me something, and I'll give you something back in return. Okay? What do you think the function is going to do? What's it going to link together? Literally those 2 things. It says, it's going to come up with a function which says, you give me the outcome, and I'll tell you the associated probability. Okay?